Okay, there we go. Okay, so tonight I want to follow up. I want to do two things tonight. The first thing is I want to follow up. I still have a number of those kind of like making cool sound examples that I want to kind of show you guys, if that's interesting to you all. You know, there's some things that I didn't quite get to, you know, ways, little production tricks and stuff like that. You know, this is all, you know, informed by my own aesthetic, so you can take it with a grain of salt. But you know, might get you thinking about how you can structure sound with these things. And then the reason that I thought, well, I can split this up is because I want to show you how you can compile a Unity project for use on the web, and kind of take you through that. Turns out that's ridiculously easy. So that can easily, half the class. And the other thing I want to do with that is a couple of you guys were interested in looking at, you know, how you trigger stuff. So we're going to build a very simple Unity project, again, just showing kind of a basic trigger, and that's what we're going to use to put on the web. And, you know, talk about the problems, you know, or pitfalls associated with that. So the first thing I want to do then is talk to you a little bit about reverb, because that's one of my favorite things to use in the world. Let me share my screen here, and I'll have to get my PD going again. Yeah. Oh, and by the way, again, we have RTC mix tilde for Max MSP does seem very stable. So we're pretty happy with it. So if you need it, you know, let me know and I'll put in a link. Maybe I'll just put a link in the class anyhow, so you can just download it, you know, when you can. Okay, share. All right. Okie dokie. Let me see, I can get rid of this. There we go. Okay, you guys can all see my screen and everything, right? Okay, good. All right, so first thing I want to do is play. I thought it'd be fun to play some examples, some of the stuff. So this is really goofy. It turns out this is kind of nice and timely because this is an Irish contemporary folk ensemble. And this is some of the most intense use of reverb that I've heard as just kind of an example. It's a band called Clonad. They do kind of very new agey Irish stuff. Anya is one of their singers, if you've heard of her. But I just want to play you a little bit of this piece. I don't know how to pronounce that. You guys are seeing the screen still when I switch like that? Okay, yeah. So this is Caslin R, or whatever the heck it's called. And yeah, it's basically a vocal piece, but listen to the reverb. It's intense. That's just so darn mystical. I mean, you know, the organ only comes in once every once in a while and just plays that one chord. And there's so much reverb in whatever the heck this bizarre Irish cathedral is that the walls, I think, are adding energy to it. You know, that's the fun you can have with these reverb algorithms, is that you can go really berserk. But the really mystical part was what they did to her solo voice. Okay, I'm going to run that by again. Okay, this stuff right here. The reverb appears before the voice. Ooh, that's mystical. Yeah, this is a technique called backwards reverb, and you can experiment with it if you want. You can't do it in real time, obviously, because you can't actually reverse time. But to do it, it's really simple. You just take a recording of something, reverse it, put on reverb, and record that, and then reverse it back. So the original sound is now forward, but the reverb all appears before the stuff. So cute things, yeah, very, very popular. So we're going to look at how you attach reverb to sort of RTC mix things. And let me bring up this. Which one do I'm going to use here? RTC mix 3.pd. Okay, and we're going to create a little granular sort of thing. And I think last time I was typing all this stuff out. I think this time I'm not going to, because we ran out of time, and I want to kind of make sure we get through all this stuff. come on, PD. Here you go. All right, and here comes the RTC mix thing. Oh, it's a little slow tonight. All right, there we go. And let's just double check here with our audio preferences, make sure I'm talking to Zoom, which I'm not, but I will be. Zoom audio device. Okay, and the first thing I'm going to do is essentially blitz out these two. Oh shoot, I just shut it off. Hang on a second. This will come right back, I think. Okay, I hit the wrong key combination there. Okay, we're going to take this out and just connect it directly into our DAC, because the first thing we're going to do is just show you what it sounds like without the reverb. We're going to put the reverb in that RTC mix, Tilda. Okay, and let's go ahead and let me load up the granular thing I have, which is over here. Okay, RTC mix scripts. Let's go to gran1.txt, open that up. Okay, and to see how it looks, okay. Oh, I know what I was doing last time. Yeah, we'll just go ahead and do this, okay. Oh, this is gonna be too tiny. Yeah, that's why I didn't do that. Okay, hold on, gang. Let me, sorry, I'm trying to remember how I had this organized for last class, and I'm not doing a good job of it, okay. But here we go, gran1.txt, okay. We don't need this, okay. All right, this is what we're looking at, okay? Basically, we're doing a nice, you know, up and down, fade up line amp envelope, which we use down here. And we're gonna generate 20 of these little grains in a hit with random frequencies between 100 and 700 hertz, okay? Now, I wanna point out one thing. I mentioned this before, but this reset 44100, when you're generating very tiny grains, we're gonna probably take this down. We're starting with 0.3, but we may take it much lower. This says how often are you going to update the amplitude as you're fading something in. If you have got a nice long fade in, you don't have to update it that long. And our default thing is 1,000 times a second. However, if your grain is only like 1/100th of a second, you know, all of a sudden you only have like 10 amplitude points, and you'll hear this weird kind of crunchy zippering sound. This will say update the amplitude every single sample, and then you'll get a real nice kind of smooth thing. The other thing I'm doing is I'm using a square waveform with the first 7 harmonics in it as my waveform, rather than just a sine waveform. And the rest of this should be self-explanatory. Choose the frequency, generate a waveform, increment the start so that the grains are kind of overlapping by half each time, and then at the very end send a max bang around. Well, let's hear what it sounds like, okay? Well, that was really smart. Oh yeah, it's already in here, that's good. So let's turn on the DSP, and we should be able to hear the grains. Okay, you guys heard that okay? You didn't hear it. Okay, I heard it. Oh, that's because I think I restarted this. Okay, hang on a minute. Good thing I checked. Audio. Yeah, see what happened? Okay. Now you're gonna hear it, okay. Ready? Here we go. Okay, so it sounds kind of annoying, you know, pretty goofy. Yeah, it's a little bit loud for me too. I'm gonna turn it down a little bit, okay. Now let's go ahead and load in our granular stuff, okay? And let's see here. We're gonna take, and what do we want? Not our reverberation stuff, okay? Let's see, gverb1.txt, okay? And I want to talk about how this is working, okay? Basically, again, we're saying RT input audio. This means that it will take audio coming in from there. So that's the next thing that we have to do, is get rid of this and get rid of this. And now we're going to send it in to that RTC mix. So we're looking at the script that's going to go into this RTC mix here, okay? And taking its input from the top part, and then all these parameters are parameters for this algorithm called gverb. We have like 7 or 8 different reverberators in RTC mix. This is the one I like the most because you can make a really big room size and give it a really long reverb time. And there's some other kind of parameters that you can fool with here. And you can create that very clownatish sort of, giant reverb if you want. It also sounds really good. The guys who wrote this basically spent like days of their lives trying different configurations of delay lines to get the reverb going. I think they're some Scandinavian country, probably Finland. They're all from Finland now. But anyhow, we're gonna use that one. And let me just take that. And what I'll do is open this up, paste that in, save it. Okay, yes. Okay, and now when I trigger this, what we should hear is the grains going through this reverberator, okay? And here we go, turn this on. And notice I'm going to hit the bang on both this one and on this one because I have to start off the G-verb too. So. So all of a sudden you get a much richer and more interesting sound, Now I'm going to do something else here. I'm going to take out this bang regeneration, okay, and just leave that in. And I'm going to go into this, okay, and open this guy up. And we're going to make the grains much smaller. Let's make them be 1/100th of a second, okay? And now we're generating 20, but we're going to generate a little burst of them, okay? So this is going to be kind of interesting because now what we're going to hear, instead of like a continuous kind of annoying granular stuff, we're going to hear like kind of little dense pockets of, oops. We're not going to hear little dense pockets of stuff. Why not? Huh. Well, we're getting off to a roaring start here. Let me try this, okay? Here we go. Oh, I know why. Because I forgot to trigger the second RTC mix. I was just triggering that one, but you have to do this first. Now we get that kind of nice. Okay, and now let's go in and let's make it be much tinier, okay? Let's give this a duration of only 1/100th of a second, okay? So let's close this off, yes. And now we'll hear. And you can kind of hear how the reverb algorithm is working now. And what's really fun is let's bring it back up a little bit more, maybe to that 1/100th of a second. And now let's really reduce the bandwidth to maybe 150 hertz to 160 hertz, so that we have a very tight kind of set of grains. Again, yes.
Sorry, I have a question.
Sure.
So the reverb is generated from a buffer?
No. What's happening is that this guy down here, okay, let me shut this off. Okay, this guy down here, it has this reverb stuff. Again, it's too tiny, you can't really see it, but that's where it's this RTC mix that is doing the reverberation. It's reading the audio being generated by the granular process coming into its inputs here. And the fact that it says RT input audio says go there. So it's not reading from a buffer, it's actually reading from a stream that's coming from that upper object. But of course, I have to trigger it. And notice it only needs to be triggered once because it has a duration of 9999. So once I set the reverberator up, it's just going to sit there and process any sound that comes in. And it'll just say reverb, and kind of do it from there, okay? Does that make sense? Yeah, question.
The G-verb, is that always in RTC mix, or is it an additional plugin? No.
Nope, it's always in RTC mix. Yeah, it's part of. If we went to the documentation, you'll be able to see it. Let's go here. New RTC mix docs. Go down to the instruments. Go down to delays. And there it is, G-verb. Okay, we also have free verb. We have these things, place and move and mroom. These are all room simulation programs that are basically your verb. Rev, reverbit, different rooms, okay? But gverb, this will give you all the documentation about what the parameters mean, some examples and things like that. Okay. Yeah, but it's always there. It's always ready for you to use. Okay. All right. Well, yeah, I changed up a few things. Now we get more of a kind of a, so I mean, these are fairly evocative sounds. You know, you can by fooling with the parameters, you can start generating, you know, really interesting, you know, patches of sound for various things that might happen in your virtual world or something like that. Okay. Right. Let me see. Where am I now? One thing I want to talk about, I put in some links in the class webpage last time. RTCMix has some very good basic stuff, like this G-verb is a good reverb. I'm going to show you a flanger later on. It's a good flanger, you know. But the name of the game with current effects, if you're using, say, Ableton or Logic or Reaper or something like that, you can get very sophisticated combinations of reverbs and delays and other kinds of things. And there's objects that you can use in both PD and in MaxMSP that allow you to access these fancier things. A lot of them are built using what they call the VST framework. This was put forward by a German company called Steinberg like 20 years ago. And it allows you to load in and use in your patch a very sophisticated sort of signal processing. The problem is that it will not translate into Unity because these are kind of like little plugins that work just within, say, PD or just within MaxMSP. There are ways of coercing these to work in Unity, but they're non-trivial. They don't work with many of the VST plugins. And a lot of times you have to have access to the source code and things like that. So if you want to just fool with PD and MaxMSP, you know, and create some cool stuff, check out the links that I put in on the webpage from 2 weeks ago, where we talked about synthesis, because they will point you to tutorials and objects where you can load in these VST plugins, and they can create some pretty interesting stuff. Okay. Just for fun, though, let's try creating a more composite system. And this is where, you know, you start thinking about sound design, and suppose that I want to have the effect of walking in to a gigantic space with like a reflective canyon wall off in the distance, all right? And I want to hit a drum or make a thump and have it hit that wall and reflect back. Now, you probably have all experienced something like that, where what you hear is not a single delay. It doesn't go whomp, whap. What comes back is because of maybe the fractal nature of that reflective boundary, you hear a whole bunch of basically reverb-like delays, where it goes whomp, sha, kind of like that. Whomp, sha. We're going to try and duplicate that, okay? And the first thing I'm going to do is add in my whomp sound. And let me see, what am I going to use for this, okay? Okay, I'm going to shut this one down. I'm going to use rtcmix4.pd. Shut this down too. And let's go here. Class stuff, rtcmix4.pd. Okay. And I don't think I shut PD off that time, but I'll double check. Okay. Sorry about this. Nope, it's still zoomed. Yay. Okay. So the first thing we're going to do is get rid of this connection. I'll talk about that connection in a second, okay? But all I want to do is trigger this RTCMix tilde and send it to the DAC, okay? And we're going to fine tune our initial drumish sound there, okay? And the drum sound we're going to use is called II noise exp1.text, okay? And just to kind of take you through this, what's going on? Well, I'm using that instrument called IIR. It's a filter instrument, and I'm going to generate noise with it. And this up here, the documentation for IIR talks about this. This is how you create the filter that is going to work. And this filter is going to be centered at 100 hertz, and it's going to be 20 hertz wide. So that's plus or minus. So it'll go up to 120 hertz and down to 80 hertz. So we've got like a nice band of noise centered around 100 hertz, which is pretty low, okay? And then the amplitude of that band of noise is 1. You can actually have multiple bands if you want, all right? Now here's what's different, okay? I have an amplitude, it's pretty high because this filter is going to cut down on the noise quite a bit. So I had to goose the amplitude up to compensate for that lower sound. That's just experience, okay? And notice that I'm not using line like I always do, where I say start at 0, fade up to 1, then go back to 0. I'm doing something different, using curve. And what curve does, if you go back and look at, say, our RTC mix documentation, instruments, oh no, it's score file, sorry about that. When you go down to the good old handy make table where it says curve, okay, it says fill a table with line or curve segments defined by arguments. And this curvature controls the curve. Well, I wanted a very percussive sound, and one of the hallmarks of percussive sounds is an exponential decay, not a linear decay like you get with line. What curve does is it says, all right, at time 0, arbitrary time 0, be at full amplitude. And then using a curvature of minus 20, which will give me a nice dish exponential like that, at time 1, be at 0. So this amplitude envelope will be basically a linear, an exponential kind of fall off. So it should be very sharp and percussive sound. And I decided to go ahead and make my duration 1, so it's going to like fit nicely within that, okay? So let's copy this, okay? Go back to our our PD patch here, open this up. Oops, shut off edit, open this up. Plop that in there. Yes, save it. Okay, and let's hear what it sounds like. We hear, there it is. Not a bad bass drum, if I do say so myself. Yeah. Okay, sorry. I'm getting carried away. Yeah. All right. Now, we want to add it to reverb, okay? But we're going to do something to this reverb, all right? We're going to make it set so that instead of just like putting into the reverberator and we hear the reverb immediately, we're going to put an initial delay on the reverb. So that's going to be like the time it's going to take for the sound to hit the canyon wall and come back. And we've got the tools to do that. Let me bring up the gverb del1.txt. Okay. Let me bring this guy up. Where is it? Yeah, right here. Okay. All right, what's going on here? Okay. First of all, we're taking our first input from the audio. In fact, you know, what I could do, I probably should have put this up here. Okay. Then we're doing some things here. We're using, we talked about this last time, this instrument called del1, which generates a single delay, okay? It puts the left channel at sort of full time, and the right channel is going to be delayed by a single delay amount, all right? We're going to take that coming in and send it to AUG01 out. Our reverberator is then going to listen to AUG01 in and then put out its sound. So we can introduce a delay in del1 that will delay the sound before it gets to the reverb. And that's exactly what we did, okay? It's going to go on forever because once we start processing, it's going to process. It's going to be a delay of 0.3 seconds, okay? And you can see the parameters up here. You know, I'm just kind of fooling around, you know, input chain, ring down to delay amp, you know, doesn't really matter, you know. And then in the reverb, the G verb, the one thing we have to do is change our input channel here. The default is 0, but that would be our direct sound because this del 1 does direct sound in the left channel and delayed sound in the right channel. So we say just listen to the right channel and that'll do it. And that will give us our delayed sound going into reverb. So that's pretty much what we want to do. Let's copy this out, okay? Let's edit that, go up here, put this into this RTC mix, paste, okay, save it, and then take our sound that's coming out of here and run it into that one too. So now we're going to have sound that's going directly into the DACs, but also sound that's going to come over. It doesn't matter which channel we use because they're both the same, and gets processed through that delay line and then the reverberation, okay? So now we turn on our audio. It's already on, that's good. And we hit the bang that will trigger both of them at first, and we'll hear. Now you hear that nice kind of like, you know, delay. I'm sorry, you guys are probably hearing some of these clicks. That's Zoom, okay? Unfortunately, our buffering with Zoom is not the best in the world. But that's pretty much what it is. We can actually go in and let's change the delay time and make it even longer. Let's give it a 7/10 of a second delay before it like really hits the ground here, okay? So let's save this, and now, oh, I gotta redo it, okay? Let me turn off the DSP, turn it back on. So again, you know, just trying to show you different ways of thinking about, you know, how you might configure your sound and imagine it being used inside something, okay? All right. Now, there's a couple of other things I want to get through. How are we doing on time? Pretty good, pretty good. We're doing pretty good. Yeah. I'm going to play you some stuff. And then, yeah, we're almost done. I'm not going to go into much detail about filters. They're used like with everything. And we've got some very fancy filters that you can employ in RTC Mix, okay? Let me go over here. If you go down into your instruments, okay, all these here are basically different kinds of filters. My favorite, I gotta say, is the Moog VCF, followed by that IIR filter, which gives you very sharp band passes. But these other filters are all very elegant. They do incredible things. This elliptical filter is an insane algorithm where you can design a roll-off of like 1 hertz, and it just brick wall blocks the sound. So yeah, we've got some pretty fancy things that you can do with this. But again, the fancy things is, you know, doing things with production. And this is actually one of my favorite examples of what filters can do. And in a sense, it's creating virtual reality just in the audio domain. This is Bjork, okay? This is from her first solo record, I believe, okay? And now you're hearing, this is like a party. And you hear stuff coming over. You hear stuff coming over the PA, and it sounds like it's coming over the PA. That's because in the studio, I read about the production of this, they actually played the music back through a PA. But you can tell it's a fake party because, like, you know, all of a sudden, once the PA starts, everybody stops, like, clinking their glasses and starts dancing. But here's some of my favorite parts, okay? It's when Bjork starts singing.
Come on, girl. Let's sneak out of this party.
So they put no reverb on her voice at all. So it sounds like she's standing right in front of you. But the part that makes it really cool is here. And this is a use of a very dramatic low pass filter, okay? So she's singing along, you're in this party, and you know. comes the filter.
We could make a boat.
Okay, so what they do, they put a dramatic low-pass filter on the program music and dropped it down. And then they dubbed in the sound of a stall door closing, and all of a sudden, you're in the bathroom with Bjork. Because there's no reverb on her voice, it's like she's right there going, I could make a bow. It's, you know, like I said, it's creation of an artificial reality, and it's very, very well done. Anyhow, I get a kick out of that. And here's another one that does something similar. This is a Finnish contemporary folk group called Vartina, and I want to listen to something. Now, listen to their vocals here, okay? Hear how they're kind of tinny and nasally? That's basically, they're just making that up. That's a filter. It's a bandpass filter meant to imitate the sounds of if they'd gone out and found these Vartina people in some, you know, Rovaniemi suburb in northern Lapland or something like that. And what happens is that, you know, they're singing slightly off key, so they're making it sound like it's an indigenous sort of, you know, field recording. But listen to what happens when they drop the filter off, and you appreciate that they actually can sing quite well in harmony. Right there. Yeah, so essentially they, again, created artificially this sense that you're hearing a field recording, which you're not at all. And like I said, they can really sing. I mean, their harmonies later on are just I just love that stuff. Yeah, it's a Karelian style of singing where they have very close harmonies. It's really cool. Anyhow, so again, filtering is like the backbone, bread and butter workhorse of most studios, and you can do a lot with the filters in terms of crafting the sound and making it have particular characteristics and things like that. Okay, I'm going to show you another technique that's used a lot in contemporary recording. We're not going to do a whole lot with it. I'm just going to demonstrate what it sounds like. You probably all know this anyhow, okay? Don't save the changes. Let's go to here and open up rtcmix4.pd. Oh, no, wrong one. We're supposed to open up rtcmix1. Sorry. Hold on, let me close this off. All right, because this is a pretty simple one. Okay. And this is a technique called flanging, okay? And let me get our sort of script here, noiseflange.txt, okay? Okay, and we're doing that bus config thing again. We're not doing the two RTC mixes connected to each other. This is doing the connection virtually. It's taking the output of the noise instrument, which just makes white noise, sending it out on aux0, and then our flange instrument takes aux0 in, processes it, and then puts it out. And then we're just going to generate noise forever, and we're going to flange it forever. What is flanging? Are you guys familiar with this stuff? I mean, is this like boring? I hope it's okay. All right. Well, anyhow, a flanger is a very short moving delay that you combine with the original signal, and the shortness of the delay is such that it actually creates an interference that reproduces a harmonic effect. It also does weird things with your spatial perception, because delays that are that short, you know, tend to get messed up in your cognitive apparatus about where the sound is coming from if you're using a stereo flanger. This one, we're just doing it in mono, and I'll play it for you, and then I'll explain a little bit about what's going on, and I'll tell you maybe one thing you didn't know, why it's called a flanger, which is a really fun story, okay? So let's put this in, okay? Save it, yes, okay? And now, okay, let's turn on our DSP, and you will hear flanged noise. Okay, yeah, that's the flanger. All right, now you can become very subtle with this, okay? I'll show you over here. These different parameters, the modulation depth, the resonance, the maximum delay, they all affect how the flanger sounds. Right now I have a resonance set at 0.7. What if I set the resonance to just 0.1? Well, let's do it out here where it's going to matter. Save this. And now we hear our flange, and it sounds like this. So subtle, it doesn't have as much of that tinniness, you know. And basically, flanging you can get very, very fancy with. This is where's the yeah, the modulation rate back here. Actually, that's maybe what I was changing. I wasn't changing the resonance at all. No, I think I was changing the resonance. Anyhow, I don't want to spend too much time with this because, again, this is the kind of thing that you can really get lost in, you know, multiple flangers doing all kinds of weird flangey things and stuff like that. Actually, I'll play you an example of a pretty serious flange. This is from a piece that I just did about a month or so ago, and I'm going to run it ahead a little bit to one part. Okay, we're going to move here to, say, 3 minutes and 40 seconds. Okay, and you're going to hear some bizarre flanging happening on the guitar solo that's happening right about now. Yeah, so that's an example of flanging. Actually, it was just an excuse for me to play a little bit of that piece. Sorry, guys. Couldn't resist. Okay, now, here's the thing. Does anybody just, if anybody knows this, shout it out. Do any of you know why it's called flanging? Here's the story. It happened with the Beatles, okay? And they're working on their song Day Tripper. I don't know if you know this, you know, dow, 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 and it's got this like flangy guitar. Well, apparently they were dubbing off, you know, going from one set of tapes to the others, and George Martin was there in the studio with John and the gang, and somehow they were playing back one tape recorder, and they're trying to like synchronize it with another one because they're going to crossfade from one to the other, and they both had a recording of that guitar track. And when they started them off, they were a little bit out of sync. One was a little bit faster than the other. So George Martin, basically, the tape, the reel-to-reel tape that they're recording with was held in place by things called flanges. And George Martin would subtly grab the flange to slow down one tape relative to the other. But as he did it, they heard this effect of that whoosh happening. So of course they spent the next couple of hours like, you know, grabbing the flanges and going, blimey, that's quite cool, let's use it, you know. And that's why it's called flanging. True story. Hey, things you learn in this class. It's amazing, okay? All right. Okay, so now we're going to go into the world of vocal processing. And this is where there's a lot of really cool stuff. We've got some things in RTC Mix, but there's a lot of VST plugins, unfortunately. What you can do is like pre-render stuff with those if you want to use it in a Unity project or things like that. But I'm going to show you a couple. This is like the biggest kind of examples of you know, heavy-duty vocal vocoding type stuff. Okay, this famous piece.
Where are we? What the hell is going on? dust has only just begun.
Yep, that's Imogen Heap with her famous song Hide and Seek. And that's a vocoder. That's where you basically take the spectral characteristics of one signal and apply them to the other. And we have a version of that in RTC Mix that's, I did a very crude thing to kind of demonstrate this, but you can get very, very sophisticated with this, okay? Let me bring this up and we're gonna throw in here, okay? And I have a sound file that I'm using, okay? This Brad demo.txt. Oh, let me show you with here. Okay, so I can make it a little bit bigger. Okay, and that's, yes.
Sorry, there is an interesting question from Nicola.
Sure.
So, maybe you can actually ask.
My question was just because before in the reverb, what you did was writing the sampling rate as the updating rate for the reverb. And sometimes, you change the sampling rate from 44.1 to 48 for whatever reason. And if there's a lot of boxes where you have to change it by hand, probably you will forget one of them at some point. And I was just wondering whether that would produce glitches or whether you probably
No. At that point, basically what you're doing is you're updating these samples pretty much faster than the Nyquist rate, or just below the Nyquist rate, and probably the filters that they're using on the converters are going to cut out anything that might be untoward. Basically, that just means that you'll probably at some point you'll skip a sample before updating the control information, but the control information will be going so relatively slowly compared to the sampling rate that you won't hear it. It's not going to be a problem. I mean, I could have said reset 40,000 and it would still probably work fine for everything, okay? Yeah, honestly, I could even say reset 20,000, 22.5 or something like that. Just as long as you get it really high, much higher than 1,000, which is the default. We've had a lot of discussions about changing the default. It's a mild efficiency issue, but it's not that big a deal. So, yeah, but essentially that's not going to be a problem. You just keep them all and they're going to be happy. Okay. So, anyhow, so what I'm doing is I'm taking this Brad demo.wave, which I have here, my sound files, okay, and it sounds like this. Hi, this is Brad, and I'm recording this as a demo for my graduate class. Okay, Brad demo.wave, okay, and this is all of these parameters, okay. This instrument is tricky to use because you have so much possibility with it. I just did a very simple possibility where I specified the pitches that I wanted to resynthesize. And what this vocoder is going to do is apply that program of my voice to basically waveform being produced with those pitches. And that waveform is actually going to be a sine wave, okay? So we're just going to hear like a weird spectrum of my voice saying, hi, this is Brad, okay? So let's do this, go back to here. I think, oh yeah, I already have it out. Okay, so let's save it. Okay, and yeah, I accidentally hit that twice. Turn on our DSP, and what you hear is, hey, I'm just like Imogen Heap, huh? I mean, so again, this is a pretty sophisticated thing to do. And again, here's the fun part. This is an RTC mix. You can actually do this within the context of Unity. You can do it in real time. You can apply to an input source coming from somewhere else. There's quite a bit that you can do. And you don't necessarily, the thing that most people use a vocoder for is vocal stuff. It's a vocoder after all. But you can apply this to any arbitrary sound and get all kinds of really wild sort of spectral effects. It's a really powerful instrument, okay? And I think the last thing that I want to show, actually there's a couple things I want to show, is another thing that's really popular for people who are doing computer music, okay? And I have a good example to play of that, okay? Oh, I don't have a good example to play of this. It's a technique called comb filtering. And unfortunately, my example I was going to play, Paul Lansky has a really wonderful piece where he uses a whole bunch of comb filtering. He used it a lot in his music. Comb filtering is kind of like a stationary flange, where you essentially just sit on a single pitch and apply that to your program coming in. And let me go ahead and just show you what that sounds like, and we'll kind of leave it. Let's go back here to my scripts, comb1.txt. Okay, very, very simple instrument, okay? All right, so again, it's referencing that braddemo.wave as my input. And then I chose a set of 4 pitches, and what I'm gonna do is, for 10 times, I'm gonna randomly go through those pitches and choose one for each second of sound that I synthesize, okay? So this is going to give me a random lookup into those pitches, assign it to pitch, and then I'll use that. And I have to convert it to CPS. If you're going to use this, write to me and I can kind of, give you the hint of what's going on here. Okay. I mean, the main part is I want to get these out on the web. You can download them and fool around with them and see what you can come up with. Okay. So let's open this up, replace our vocoder stuff with, with our comb filters. Oops. I think I hit the wrong thing here. Here we go. And copy and paste. Yeah, there we go. Yes. And now what you'll hear, still on, is my voice being run through those like randomly chosen pitches of the comb filter. Oh, let's turn off edit mode. Hi, this is Brad. 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 That'll really drive people crazy. That's pretty annoying, but you get the idea. This comb filtering also has a very well-known image in the popular consciousness. If you drop the frequency down to about, the F below middle C, an octave in F, an octave in F, octave below middle C, go down to the F, and you go, I am your father. I mean, they used comb filtering on Darth Vader that made him sound like nice, mechanical, and evil and stuff like that. Okay. All right. So that's comb filtering. Yeah, let me. Okay. I want to show you 2 more things. What are we doing on time? Oh, actually, we're doing pretty good on time. Maybe I should show you one other thing. Yeah, let me show you one other thing because it's a really good workhorse. Yeah, Nina, question.
I was wondering if you're going to show us something with granular synthesis in particular.
Not beyond what I'd done earlier, to tell you the truth. Let me show. I am going to show you how you can access like fragments of a sound file and sample them. In fact, I'm going to do that right now. And
yeah, like something glitchy. Yeah, that would be fun.
Right. And we can maybe granularize a bit of that or something like that. Okay. Actually, there's a good demo for RTC Mix that does that. I'll have to bring up Max MSP for that. But let me bring this up. Yeah. What is the name of the sound file? Ah, baby. Okay. Yes, this one. Okay. Now, this one. Okay. I'm accessing a different demo sound file. And this is the one that I'm accessing, okay? It's this guy right here, where all I did was pick up the mic and go, ba, be, be, bo, boo, okay? So I took that and I ran it into Audacity, okay? And what I did was go along with Audacity, and I found out what the starting point and the duration was of each of these kind of ba, baby, bo, boo things, okay? And what I did was I then put that into an array in skits. These are the actual points in that sound file where it goes ba, be, B, bo, boo. All right, and I figured out that the duration of each one, if I put a duration of 0.5, I will always cover the whole thing. And then I did do a little amplitude thing here where it starts out at full amplitude. For 90% of the sound, it'll be at full amplitude, and then it will fade down at the very last 10%. That's just to eliminate any clicks and things like that. And what I'm doing is basically, I'm going to go in here, and I'm going to get my input skip. I'm calling it inskip. And I do that, I didn't explain this in the last one, but trand gives you a integer lookup. So it'll give me a 0, a 1, a 2, a 3, or a 4. I don't want it to give me, like if I used IRAND, it would give me like a 2.931. RTCMix would interpret that as being 2.931. It would be 0.931 between 2 and 3. So it will give me some number in there. I want to give just the integer numbers. So trand does that, and it will basically do it between 0 and the length of that inskips. So that will give me my integer index, which I can then use for inskips the array. And
Brad,
give me,
can you say that last sentence one more time about how it would interpret it if you did it the other way?
okay, if I turn this into, let me rewrite this a little bit, okay? Okay, I'm going to say this. I'm going to say that my my index is going to be equal to. I actually had done this in my other thing, and I didn't do a good job of explaining it. Okay, so here's how it works. trand will give me a number between 0 and the length of the inskips array. That's done up there. If I say len inskips, it will say, how long is it? Well, it's 5 things long. So that will give me 5. So this will give me an integer thing between 0 and 5. If I said IRAND, it will give me a floating point number randomly between 0 and 5. And that number, chances are, is not going to be a 0, a 1, a 2, a 3, or a 4. It's going to be like 1.5, 1.593. IRAND, the way that RTCMix arrays work, the same way that like you can specify your lines like that, is if you say, give me something that's at 1.5, it will actually give me something that's 0.5 between 1 and 2. So I'll get a number here, which isn't the number that I want, because that will then put me into the sound file some weird part where it's not actually right at the beginning points that I had carefully kind of gotten from my Audacity thing. So that's why I'm doing this. Once I get that index, then I can access that array using that index and get exactly that number that I want. Okay, does that make sense? Okay.
Yes.
Alrighty, so let's hear what this sounds like. Okay, let me copy it all out here. Get rid of our comb thing here because we're not using it anymore. And go out here, get rid of this because we're not using, oh, that's what we're using. Right. I'm getting confused. I have too many windows open. Okay, here we go. Put this in, put that in. And now what we're going to hear is it will, for 20 things, it will randomly go through, pick out one of those, and then advance the start time by 0.2 seconds. So 0.2 of a second is going to generate one of those ba, be, beep, bo randomly. And here's what it's going to sound like.
Boo, ba, be, boo, bo, boo, boo.
Oh, you know what? I'm thinking, that's not right. I forgot to change it back to trand. So sometimes you're hearing stuff that's not right at the beginning of the things. That's a good demonstration of what happens with IRAND versus trand. So let me go back and change that now to trand. And you'll clearly hear the difference, I hope. Okay, here we go. Okay. Okay, now, if we wanted to turn this into something granular, let's make our duration be 0.05. And because we're using such a short duration, let's say reset 44100. Okay, and let's make our duration start plus 0.2, and let's hear what that sounds like. Okay, because basic granular synthesis is doing just what we did, but with much tinier durations, okay? So hopefully this will be kind of granular, and we can make Nina happy. Okay, say yes. Here we go. Audio is on. Let's hear what it sounds like. Yeah. I'm just goosing the start button myself, so we can get this over and over again. You know, otherwise I'd have a max bang coming around or something like that. But again, that's granular synthesis. Okay. All right. Cool. Right. However, one of the things that's not so fun about it is that it's just doing everything at the original pitch. What if we want to shift the pitch on it? Well,
is there like a limit to how tiny you can make the grains in RTC mix? Obviously, I could type in any number, but where's the limit of like when RTC mix it's too much for it to handle?
It's sample. You could go down. You could actually, you know, if you wanted to, you could like get one sample.
Yeah, because like when you if the farther you take it with granular synthesis, the more like the real granular synthesis starts happening.
Yeah.
You know, like if you make those like even smaller, you know, like you start getting the single tones that are, yeah, you know.
Yeah, yeah. It's a very powerful synthesis technique, you know, and the trick is just to play with the parameters and see what you can come up with, you know. But RTC mix will go down to the sample, you know.
Okay.
So you could actually like reconstruct a whole waveform, which might be kind of strange. Yeah, I've used samples. I think I used a sample size inadvertently of 1,000th of a second once, and that's a yeah. That was, I think that means that the actual grain size was 44 samples long. So yeah.
Yeah, to actually be considered granular synthesis, I think that like the strict definition is it has to be like each grain has to be less than 100th of a second.
Yeah.
So like 0.01 is as slow as you could possibly do it, and it would be granular synthesis.
Right. Unless you're old and tired like me. Okay. All right. Let me bring this up, okay? Here we go. Jigga 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 class stuff. RTC mix tricks. What do I want? Trans one. Okay. Here we go. Okay. And this isn't granular synthesis or anything fancy like that. It's just showing you how this instrument works, okay? And we're going to be using it on another sound file that I recorded, which sounds like this, okay? Go up to my sound files. Here we go. So it's just me saying, ah, right, okay? Let's put it into our RTC mix thing here, okay? All right, paste it in, okay? And save it, yes. And now, what this does, let me show you the score for it again. Where did that score go? Right here, okay? It accesses this as its input. And trans is an instrument that basically just takes a transposition value and just shifts the whole thing. You know, it just does a resampling. It doesn't do anything fancy. It doesn't time stretch or time compress or anything like that. And this is an octave point pitch class. So minus 0.12 will shift it down by 12 semitones, okay? Now, here's the thing. When you shift something, basically, you change the duration with this instrument. My original duration, I'm saying, is 2. And given that transposition value, what's my new duration going to be? If I'm shifting it down by an octave, it's going to be twice that. So this is actually going to be 4. So new dur will be appearing as 4 there. So that's a way of being able to play the entire sound file you want, is by keeping track of your length with that handy little function, okay? You got to put in. Let's hear what it sounds like. Oh, it's in edit mode still. So that's kind of evocative, you know, and the really fun you can have is you can do things like transpose it like way down, okay, like this. Q4. Okay, let's see what that guy sounds like. it's going to be 8 seconds long, too. Okay. So, run that into a nice big reverb thing, and it sounds pretty cool. Okay. It doesn't take much to make some cool sounds sometimes. Well, I like it. Okay. And the last thing that I'll show you, there's actually, I think, an object that'll do this in RTC Mix. We're about to leave. Yeah, there's more I could do to show you some of these things, but we're running out of time because I do want to show you how to do the web thing, okay? So I'm going to quit PD now, okay? Quit my text edit, okay? And show you this application. This works on both Macintoshes and Windows, and it's free. This thing called Paul Stretch, okay? Where is it?
There is no way that you said we're running out of time and then decided to talk about Paul Stretch.
So you know what this is, right, John? Okay.
Yeah, I could talk about Paul Stretch for like a whole day.
It's just, this just makes instant cool music, okay?
You can take any sample and just stretch it out to 3 minutes long, and you've written like a beautiful piece of music on that. Like,
right.
Like,
you can go on like YouTube and you can find things like, the first 10 seconds of Steve Reich's Music for 18 Musician stretched out to 800 times its length or something. It's just like that. Let me think. Yeah, I think I've got enough time. Yeah, let me do this real quick. Basically, what you do is you bring in a sound file, okay? Let me find a sound file, okay? Maybe I'll get my...
This is something I use in my pieces all the time.
Oh, really? So you guys know about this? I don't need to show it to you then, okay?
My teacher showed me this like a few years ago, and I think even if you listen to some of my music, you can recognize it's been done in Paul Stretch.
Yeah, it's after a while you go, hey, yeah, I know that. Okay.
This is so
Yeah.
fun.
Yeah, it
And
really
it's
is.
also amazing in a way.
Yeah, basically, yeah, you guys know what's going to happen. It just basically, it takes any sound, stretches it out by like an insane length of time, okay? So let's go here. Let's take my, let's take my Brad demo, what the heck, okay? All right. Where it says, hi, this is Brad, okay? So I put this in, okay? And they've got all these cool parameters here. This is stretching it 8 times. Let's stretch it by like 281 times, okay? And I could play it now. Yeah, you get the idea. I mean, this is just an insane algorithm.
But all the like harmonizing options are also very cool, and that you can like delete some of the octaves or add some of them and amplify them. That's really fun.
It's a seriously intense thing, yeah, the guy that did it. What happens is basically this is doing an FFT resynthesis. We actually have that instrument in RTC Mix too. But the thing is, if you do a straight FFT resynthesis and stretch it way out, it sounds very static. What he did was, it's a technique called randomizing the phases of the resynthesis. And it gives it that kind of, character that the sound is somehow a bit alive and everything. And Nina's right. There's a bunch of parameters you can play with. Again, the link is up there. You can download it. It's free. It's amazing. It's really cool. Okay.
It also lives inside Audacity.
It does.
It's one of the effects that Audacity just has.
That actually is true. That is actually true. Okay. All right. So we got about 30 some minutes left. That should be enough for me to show you this. And if I do run out of time, I've got it kind of pre-made. Let me open up my cheat sheet here. Okay, open a recent file. No, I don't want to do that. Open. browser. Sorry guys. Okay, outline 9. Yeah, there we go. Okay. Here we go. Open. All right. Here's what we're going to do. Okay, I'm going to build a really simple Unity scene. And again, because I know people were interested in triggering, it's going to be a scene where we're going to trigger a sound. Okay, and partly that's because I need to show you what your constraints are going to be with sound. So let me go ahead and bring up my Unity hub, and I'm going to start a new scene here. Okay. All right, and all right, let me go here, and I'm going to go up one to week 9. Select that folder. Okay, and we'll call this g6611 slash week 9 slash web demo. Okay, that's gonna be a project. Now, you're gonna notice that I'm now using a new version of Unity, and I'm going to explain to you why that was the case, okay? Here it comes. It's going to bring up Unity, open up my project. Yay, yay, yay. Keep opening, keep opening. And yeah, the other thing, again, I've pre-made some stuff. We're not going to actually compile the web thing because even a very simple project like this, it takes it about 5 minutes to compile it. And I thought that's going to be pretty boring. So let's go ahead and get this going. All right, come on, Unity. Here we go. All right, Unity. Yeah, maybe I should have had this part pre-made too, sorry. Again, it's gonna be pretty simple. We're gonna basically just put down a plane. We're gonna create an observer, and then we're gonna put like a doorway. And we're gonna make the doorway a trigger that when we go through the doorway, it's going to trigger a sound, okay? As soon as Unity gets going here. Yeah, I keep forgetting that Zoom also like taxes the resources of these machines a bit. So, you know, it's kind of like swapping back and forth right now. Here we go. Here we go. Boy, this is taking a nice long time. Ah, here we go. Okay. All right. So let's go ahead and you know, start building our stuff here. Okay. Let me see. I want to bring this. I'm going to put you guys down here. Okay. And first thing we're going to do is here's our scene. Okay. I like to see the game, so I'm going to bring that down here too, so I can see what I'm doing with the game. Okay, let's put down, first of all, our plane, okay, just to give us some kind of grounding here, okay? So I'll say plane, okay? There it is. And let's reset it to 0. Oh, it already is, looks like, okay? Yeah, so that's basically where we are. Oh, shoot, I kind of messed it up here. Let's say reset. Okay, there we are, okay? And let's now create a capsule that will be our kind of creaturey thing that'll be the observer. Okay, so let's put our capsule down. Okay, and let's make it be, say, let's give it a little bit of height here. Okay, and let's bring it back by -5. Okay, so here we have our capsules on the edge of the plane. And now let's make the camera be a child of the capsule, because that's a good thing to do in the way we tried to work. And let's reset the camera, okay? And let's also put the camera up on the top of the capsule, okay? So now we've got our capsule, our camera, our plane. You know, we're in pretty good shape here. Let's save it in case we do something wrong and it crashes. Let's also then bring in our observer move package so we can move this around. So I'll pull this down here, okay? And let's see, where are we? Oh, okay, it's still compiling. We'll take a minute to compile. Okay, let me now put this on the capsule. And let's rename capsule observer just because it's a nice thing to do. observer. Okay, and let's go down here and set our speed before we forget about it. We'll make it 3 going frontwards and backwards and side to side, and our rotation speed will be 1. Okay, so now we can probably move our observer around, but what's the point? We don't really have anything to look at. Let's go ahead and build our plane. Okay, our not plane, our doorway. Okay, so for that we're going to use a cube. Okay, and the cube is right in the middle. We're going to make it be, say, 3 units wide and maybe 5 units tall. And let's get it very thin in the Z. Let's make it be 0.1, okay? And now let's position it up by like 3 units. So we've got a nice floaty kind of doorway there, okay? But I want the doorway, I mean, everything is just white and really boring right now. I want to actually add some stuff to it. So let's go down here and let's add some material. Okay, and the material we'll call trigger mat, because I forgot what we want to do just for fun is instead of just calling this cube, we're going to call it trigger. Okay, so let's go to our trigger material and let's maybe give it a nice red color. There we go. And now we can put it onto our door. And now, yeah, we have things kind of ready to go here, more or less. Okay, let's try running the game and seeing what happens when we like do stuff. Okay, so watch the game down here. Okay, here we go. I can move forward. I can go through the door. I can go back through the door. You know, I can look up at the door if I want to. I can look down at the door, okay? So essentially, we're kind of set to now add the stuff that we want to add that allow us to play back a sound file, all right? And first thing we're going to have to do is add a component to the trigger that detects when it's been triggered, all right? And we're going to do a couple of things. First of all, we know that if we're going to do this, we need to set is trigger on the box collider. So I'm going to click that, okay? Then we can go ahead and collapse this for now, all right? And now let's add a component. And we're going to add a script, new script. And we're going to call it trigger script. Okay? So there's our trigger script that showed up nicely for us. And let's go ahead and put in a thing that will tell us if we're actually triggering things properly. So let's double click on this to open up our editor, which will take it a minute or two. All right. And what we're going to do is there is a function that gets activated when you click that is trigger. And that function is called onTriggerEnter. Now, there's a whole family of them. There's onTriggerExit, there's onTrigger whatever, you know, but we just want to say when we enter the trigger, we want this function to happen, okay? So we're going to fill that out. Here we go. With a very basic thing. We're just going to have it tell us when it got triggered, okay? So down here, we're going to add this, okay? And again, this is the fun part about Visual Studio, is I can just start typing on trigger. I should be able to start typing on trigger. Well, why didn't it do that? Oh, you know why? Because I think it has to be on. Yes, it was a capital O, okay? On trigger enter, there it is. So I hit that. And it fills me out. And let's just say now, if you're going to fire this when you enter the trigger, let's just say debug.log. Hey, so we're going to see if it's working. So I save that. I go back to Unity. What the heck is going on here? Okay, well, it reloaded the script assemblies. I'm happy about that, all right? So now, if we go to our console, hopefully, when we do this and go through the trigger, we'll see it say, hey. But you know what? It's not going to do that. Watch. I go through. It didn't say, hey. I go back. It didn't say, hey. Why didn't it say, hey? That's because my observer needs to be the kind of thing that can make something trigger. And to do that, we're going to have to add some physics to it, okay? Let me now collapse this capsule collider and this mesh renderer. We're going to come back to that in a second. But let's add a component, add physics. We need to make it a rigid body, because it's the rigid body that will actually hit the collider and go, hey, you triggered something. Now, the other thing I'm just going to go ahead and do, rather than just like take you through and say, oh, look what terrible things happen. Actually, no, I can show you the terrible things that will happen, okay? This will actually work now, okay? When I hit this play, okay? Now watch what happens when I go through the trigger. Here it comes, okay? Hey, look, see down there in the console? It triggered, all right? So I can go back. Hey, I'm triggering. Yes, I'm triggering, okay? Let me look around a little bit, you know, I mean, all kinds of stuff happens. Well, uh-oh. Ah, look, I fell over. That's a problem, okay? It's kind of pathetic, isn't it? Because right now I can't really do anything. I can just kind of hop the poor thing around, you know, and maybe rotate a little bit and look at the sun, but I'm dead, okay? That's because I'm using gravity. And I want to use gravity because, you know, that's going to help me kind of interact with the world. What I have to do is set constraints where it will freeze my position. I'm going to freeze it in all the X, Y, and Z planes so that when it hits something, it's not going to rotate weirdly and fall down and do bad stuff. This will basically keep it in the same position, but it still allows me to move it. It doesn't freeze its movement, okay? So at this point now I can go in and, well, shoot, I don't even need to show you because, well, I already got it started, you know, here it goes. So here I go, I can trigger, I can trigger, I can trigger, I can rotate around. It's not gonna fall over, life is good, all right? Now, I want to use this to trigger a sound. And this, remember when I told you at the very beginning of the class that Unity, basic Unity has very restricted sound capabilities? Well, basically, pretty much all you can do really in Unity is trigger sound clips or sounds that you've pre-recorded. They have some rudimentary flanging and some a very terrible sounding reverb and some echoes and things like that. But there's just a handful of signal processing algorithms. But on the web, when you compile Web Unity, you are restricted to using the Unity stuff because it looks nearly impossible to get RTCMix to work inside Unity on a WebAssembly. I'm going to look at it this summer, and I hope I can get it fixed because it'd be a wonderful resource to have. But what we're going to do is we're going to use the Unity system. Okay, I'm going to collapse my rigid body here. Okay, so I have enough room to show you everything. I'll collapse the observer move. Okay, we're going to add an audio source to this. Okay. All right. Now, normally when we use RTCMix, that's all we do because RTCMix takes the place of the audio clip. But in this case, we need an audio clip. And I recorded a really wonderful audio clip for going through this stuff. And this is it. So every time we go through that door, we're going to hear that sound, okay? So I'll just take this and put it down here into my assets. Once I do that, I can take it and put it as my audio clip for this thing, all right? And we can actually check this by looking on this. We can actually play it back here if we want to, okay? Yes, it does indeed go, we're happy about that, okay? But how are we going to get this audio source? Where did I put the audio source? Oh no, I put it on my, I put it in the wrong place. I put it on my observer and I wanted to put it on the trigger. So let's remove this component here. Sorry. Add component, audio source. Now I have to boost this over here. Make my audio clip. Now, play on awake. If I just hit play now, we would hear that. But we wouldn't hear it from the trigger because I have to put the playback in that on trigger enter. How do I do that? Well, you go into the script. This is actually the last thing we're going to do before this actually works, okay? And then I have a few things that I need to show you about compiling it. Okay, so we want to basically put in here something that will play that audio source. Okay, so we need to basically create a variable, audio source. It's of type audio source, and we'll call it just bzz. And in start, we're going to have to identify that component that we have added to our thing here. So bzz, bzz, okay. That's going to equal get component audio source. So this variable, when this happens, will then be attached to that audio source component. And now we can do stuff with it, all right? And the way you find out what you can do is you can actually double click on that and hit Command tilde, or Command a single quote, I think, and it brings up the documentation for it, shows you how to do it. And look, oh, that's what we're going to do. Play the audio you attach to the audio source. Ho, ho, that's exactly what I wanted to do. So instead of debug.log, what we're going to do is we're going to say, oops, we're going to say bzz dot play. That's all we need to do. Okay, we have our source. It's got the audio clip attached to it. We get that source and we just say play whenever you enter a trigger, okay? So let's try it out. So we go over here, it's compiling. Now we hit play. And there we go. Oh, and we hit it backwards. Oh yeah, we're just having fun. Okay, so this is like the greatest game ever, all right? We want to put it on the web. How do we do that? Well, this is where it's surprisingly easy, but you have to be careful, okay? First of all, you have to go to your build settings. And the default is you just build for a PC or a Mac or whatever you're on or something. But we're now going to select WebGL, okay? And then we switch our platform down here. So now it's all like doing this WebGL-y stuff, all right? Switching the platform, okay? It's taking its time, but it's switching its platform. It is taking its time, and it is switching the platform. Notice you can build for other stuff here too, if you want to. You can build for, you know, iPhones. You can build for Android phones. You can build for Xboxes if you want, you know, but you have to know what you're doing. All right, okay, here we go. Okay, I didn't realize it was going to take this long. Okay, now we switched our platform. Well, maybe. Not quite yet, okay? All right, now we switch our platform and we can build it, but we gotta do a few things first. We have to add the scenes that we wanna build. Now we can actually go down to scenes and drag them up there, or we can simply say add open scenes and it will add the scene that we've been currently working with, okay? Now, at this point, you might be thinking, this is wonderful. I can hit build and it will work. Well, it won't, because there's a couple things, there's just one thing that you need to do that a lot of contemporary browsers, they tried to set it up so that they could compress the application so it would be a very fast download. Especially when you get larger games on the web, it takes it a while to download. But the compression stuff, browsers often don't decompress it properly. So we're going to go to our player settings. And down here, under publishing settings, that might be collapsed, okay? Let me bring this up a little bit. Oh, shoot. There we go. Okay. Publishing settings might be collapsed. We have to go down here, and where it says compression format, you have to disable it, okay? I discovered that the hard way, because I tried to make it go, it didn't work, it gave me errors, and I had to Google it, and it says, oh, disable your compression, and life will be good, okay? So I can now click this off, all right? And now I can hit build. And it will ask me where I want to place it. And I could call this something like webness or something like this. And it will place it right in my same folder with all the other stuff for that unit thing. I'm not going to hit build because, like I said, that's going to take 5 minutes or so to build it. What I have done is already pre-built some stuff. So I'm going to quit this Unity and show you that pre-built stuff, because I also have to show you a problem that happens with another Unity, okay? So I'm going to quit this. Here we go. Okay. Quit this because I don't need to look at my script anymore. Come on, quit. Okay. And I'll go here to this one that I had already made, okay? And I have down here webness. This is what it builds for you, okay? Now, you think, oh, there's the index.html. Maybe I can just try it with one of my web browsers right here and now. And I'll take it over and I'll drag it onto, say, Firefox, and we'll see if it works, okay? But here's what'll happen. You'll get this error, okay? Unfortunately, it doesn't play well with trying to run something on your local machine unless you make some changes to your browser. That's a safety feature because they don't want browsers like, you know, downloading malware and then running your machine and doing all sorts of stuff. And I'm thinking, oh my gosh, it's not going to work. Well, no, it actually works fine. It's just that we have to put it onto a web serving platform. And you know, you all probably have your own website or something like this. You know, basically you have to take this whole directory, this webness, and just transfer it up there. So that's what I did. And as a result, let me not use Safari. I'm going to use Chrome because it's a little bit nicer for this, okay? I'm going to start up Chrome. And I put it in my top level of my web server. I can say webness, hit return. And look, it's Unity stuff. Yay! Let me bring you guys back over here if I can. And look, it's our Unity thing. And look, if I go through it, it goes big. So I'm actually playing it in the web browser at this point, okay? That's all there is to it. Again, it's not that hard. You just have to be a little patient. And you have to realize that, for example, about all you're going to be able to do is probably pre-render audio clips. And, you know, they do have a kind of a fancy mixer thing where you can fade stuff up and down, but that's going to be beyond the scope of this class at this point. You can read the documentation about that. Maybe I'll put in a link on the webpage to some tutorials about it, because it is handy and it is a good thing to know how to do, okay? Essentially, that's it. Now, I want to show you something that I ran into that was also a problem. Okay, I'm going to go back to the Unity Hub. This is why I'm using a newer version of Unity, okay? Let me go to my older version, which was 2019.2.17F1. Okay, I'm going to click on that, and we're going to load this guy up, okay? This will take a second or two. Come on, Unity. All right. Here we go. It's loading, it's loading, it's loading. It'll be done in just a second. Yes, that's what I say. It'll be done in just a second. There we go. Okay. So this is, I was using this old, you know, 2019, actually the first part of 2019 Unity, all right? And I went down here and I thought, oh, golly, I've got this wonderful thing made. Let me go to my build settings, okay? And I hit WebGL, and it says, oh, no WebGL module loaded, okay? So if I open the download page, it downloads an installer. That installer does not work on Macintoshes, okay? I found that out the hard way too. It says, use your Unity Hub to install it. So I thought, okay, I'll go out and I'll use my Unity Hub. So I go to here and I go to installs, and under here, these three little dots, there is add modules, okay? So I go to add modules, and look, WebGL build support is right there. So I click it and I hit done, and it downloads it, and it says it installs it, and it is not installed. This is too old now, okay? I could have upgraded to another version of 2019 and that would have worked, but I said, what the heck, I'll just go for the latest one at this point, 2020.3, and I think all the 2020 Unities have WebGL already built into it. In fact, you can't even add a module right there. So I downloaded that, it worked. Just be aware that if you have problems loading in a WebGL module, you might have to upgrade your Unity at that point. Okay. So that's it, right? Oh, good. There's all good chat stuff that I can read afterwards. Did I miss out on anything important? I don't know. Oh, here's one thing.
Yeah, Juan had a comment about PD.
Okay.
With this first patch where there were two RTC mix objects and there were two bangs, one on the left side and one on the right side. I think that it's about that one. And so the left one went to the leftmost outlets to both RTC mix objects, and the right bang went just to the right
Just
outlet of the upper.
Right. Right. Here's why that was. Okay. When I started off, I had to start off the bottom RTC mix tilde, but I only have to start it once because that's the thing that was running like a G-verb or a filter or something like that. And that basically has a duration of like 99999. Once I start it, it just goes. The upper one, where I was like generating bursts of sound, I need to be able to bang that again and again. So what I did was I initially hit them both so I could hear the sound. Then the second bang that only went to the upper one, I could just hit that without having to re-trigger the G-verb. If I re-triggered the one that had the G-verb in it every time, it would add more G-verbs every time I tried to process the sound with it. So it would just get louder and louder and louder, and then eventually it would distort. Okay.
Okay, so two objects are just a trick, like a way around it. You mean? Or
yeah. Want me to show you? Want me to share my screen again real quick?
I mean, I'm not sure if that was the question. Is it necessary to connect the trigger on the right to both RTC mix object? I guess, was it connected?
No, it should have been only to one. It should have been the bang on the right should have only gone to one object. Okay.
No, my question is the first bang you connect to both the RTC mix object, right?
Yeah. Let me show you that. Okay.
It's not necessary to connect for the first one, right? Because you're gonna bang it later anyways, right?
Right. Let me show you guys. Okay, I just want to make sure that you got this, okay? Because yeah, class stuff. This is one that has, I think, several in them. Okay. Hold on a half second. This will come right up. This is also true in Max MSP too. I just decided to do it in PD this time because that was before we had the Max object fix, and I know a lot of you are using PD too. It turns out I'm pretty impressed with PD. It was very stable, and yeah, it kind of did the job. But it does take its time starting when you're using Zoom. Okay, come on, come alive. There we go. Okay, I'm not even going to bother to generate any sound. I just want to take you through the logic of the patch, okay? So it should appear any minute now. It should appear any minute now. There we go. Okay, yes, okay, right. See, so this one, okay, this one, basically the bang is triggering this and it's triggering that, okay? Now, what you saw in other ones was, oh shoot, what's the pure data thing to get a bang down?
Subby?
Yeah, there we go. So when there's a second bang that just goes to the top one, I only trigger this one once because that starts out the processing of like the reverb or something like that, okay? This one I hit at the same time so I can hear it. But then if this one is generating just a burst of noise, I only want to trigger that one because it will send the sound to this one that's already running. If I hit this one again, it would start a second G verb. If I hit it again, it would start a third G verb. So all of them would start reverberating. And that's not what you want. You just want one G verb that's like handling the reverb, okay? And then the upper one is your sound source, which might be little bursts of grains or Brad going, hey, how you doing? Or something like that, okay? Does that make sense?
Yes.
Okay, good.
My question is just, if we do have two bang objects, do we still need to connect to both of the objects for the first one?
Not necessarily.
Okay.
As long as you start the second one first, then you can just wait and start the first one whenever you want to. So they could both have separate bangs, one to start one and one to start the other. I just did that because I'm kind of lazy. Okay.
Okay, sure.
All right. Well, it looks like there's some other good stuff in there. John Levy shared a video that looks kind of fun. Yeah, that was earlier. I think that's when we were playing like Irish folk music. Okay.
It's with you.
Yeah. Oh, Nicola. Yeah, the Max for Live, the reverse reverbs, those are fake outs. Those aren't actually reverse reverbs. They just like change the tail on it so that the reverb sound actually sounds, but it's actually connected to the thing in the future, because you can't actually reverse time live.
I
No,
think I said that. No? I think it was my comment.
just
Oh,
a
was it?
fake then, or what?
Yeah, well, it's basically, normally you get reverb, it goes, pah. You can modify the amplitude envelope for the tail and get it to go, pah, kind of like that. And then it sounds like it's reversed for the next sound you hear, but it's actually being generated by the previous sound. So if you have a sound that's going bum, 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 and then you do that reverse amplitude curve, it's like bum, 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 like that. But the is coming from the previous object.
Yeah, yeah, absolutely.
Yeah.
No, anything else, I mean, would require something more than max MSP.
Yeah. It requires the power of a god. I'm going to reverse time, no problem.
Is there a standalone version of Paul Stretch?
Yes. In fact, that's what I was using. I'll put the link in, make sure that it's there. In fact, I think I put it in the last class, but I'll put it in again because it's such a cool program. Runs on Windows as a standalone program, runs on Macs as a standalone. I don't know about Linux, but it's also in Audacity. I believe there's also both PD and Max MSP objects for it too. I mean, it's been enormously popular. like Nina said, after a while, you can go, yep, there's Paul Stretch. Okay, all right. Answer the question about the sampling.
A lot of computing power. Can you do it in real time?
No, it's very.
That's the amazing thing about this program.
Yeah.
That it doesn't, and it runs on like surprisingly. I don't even remember if I checked if it would run on my OS, but there is no problems. It's great.
Yeah, it's it's just like running a single FFT and then it's just resynthesizing the thing, and that's kind of trivial with today's hardware.
Yeah,
it's amazing. It really is an amazing program.
And there's a max object.
I believe so.
I would just download the standalone. It's the easiest way.
Yeah, I'm not sure how well it works in real time. I mean, you actually saw a little bit of real time in this when I was like moving the cursor to jump to a different part of my voice being processed. I mean, that's essentially suggesting that it's doing it in real time, and you might be able to do things like that with a Max or PD object. I don't know what other parameters they've exposed though.
I see, because I was doing time stretching before with Spear, and Spear always takes some time to analyze and so forth.
Right.
Like, this is not really do it real time, or at least not if you don't want to have buffering in between, which I don't know what's going to happen to the rest of the audio while it's buffering.
Right, and Spear is really designed for people who want to use it to extract data, you know, and a lot of its processing is also doing the partial connecting, you know, like Audio Sculpt. You know, Paul Stretch doesn't do any of that. It just says, here comes some sound, I'm going to make it long. You know, that's all it does.
And it's user friendly because you can just touch like tweak buttons and like, you know, stuff. Just touch it and see like, oh, this is fun, or I like this sound. And you don't really have to like know before you start doing anything what you want, or yeah, there is some just you can just have fun with it.
Yeah. Hold on, I got to check something out here. What is that? Huh. Oh, yeah, I was just looking at the video that John posted. I thought he'd found some of my old punk rock videos. That'll be a challenge for you, John. Because it's a bit older than a decade ago. Those are. Okay, gang. Hey, we're about out of time. Yeah, good class. Again, you know, the main thing to do is to just try some of this stuff and see how it works. Again, compiling for the web, you're going to have to be a little patient, but it does work, you know. And like I said, next time, Laura, we can ask Laura more questions about what exactly. There's a lot of things inside Unity that you can't use in the web version too. Certain graphics operations and things like that. And Laura can, you know, speak to some of those. You're limited, I think, just to the number of shaders you can use. I'm not sure about that. And Laura can also talk about, you know, how you can go about setting up. There's places where you can actually just upload your finished build and it will run. You know, it's kind of like a temporary hosting type thing where you don't really have a fully fledged domain, but you can still try these things out and run them. Simmer.io, I think, is one. There's a few others. But Laura can speak to a lot of those things. So should be good follow on for this. Okay, gang, I'm going to shut down the recording now.